Hi all, I'm Tyler Crowe, a Senior Product Manager at Firebase and Google Cloud.
And I'm Michael Bleigh, an engineering lead on the Firebase team.
Today, we'll walk through a movie review app that was built on Firebase Data Connect. Then, we'll add an agent live. So, about a month ago, Michael and I were thinking about what we would make for our I/O demo. We came up with the idea for a movie review app and decided to go to Gemini to help us get started.
Thanks, Tyler. Data Connect integrates with Gemini to help you go from idea to full app data model with just a prompt. So that's where I started. In just a few seconds, I have a great start for our app with tables already defined. If I want to make changes, I can ask Gemini to do the updates. Once I'm ready, I can click Deploy, and Firebase will provision a Cloud SQL Postgres database and populate it with the schema for my app. But let's jump forward in time a little bit and take a quick tour of the app that we've been developing. The home page shows new releases, top-rated movies, and a selection of recent reviews. Each movie shows its average rating. I can also browse the selection of movies with a rich filter interface, allowing me to select the rating, genres, and release years I'm interested in, as the data is quickly filtered to reflect my selections. If I visit a movie's detail page, I can see the cast and reviews. I can also log my own watch of the movie. Let's say I watched this movie last night at home and give it a quick review. My review will show up on the movie's page as well as in my personal watch history. Finally, I can search for movies. Our app's search is powered by Data Connect's integration with Vertex AI text embeddings. When I search, it will find semantically relevant movies, not just close text matches. Here, for instance, when I search for mythical creatures, the top results are all highly relevant for my search, even though none of them have mythical creatures in the title. As you can see, my app is off to a great start with many features already implemented. Let's learn a little bit more about how Data Connect is powering our app. Back to you, Tyler.
So now that we've seen the app, let's see where it gets its data from. Firebase Data Connect brings the ease of use and rapid development of web and mobile apps from Firebase, matched with a relational database offering with schema and powerful querying. I'm happy to share that Data Connect is now generally available. We've added new features like Gemini AI Assistance, where you can tell Gemini your app idea, and it will generate your schema, queries, and mutations needed to build your app. We've expanded the query capabilities of the service as well as support for popular frameworks, React and Angular. So what does Data Connect do for you when you want to build your next app? We built Data Connect on a single principle. You write the query, we do the rest. When you craft a query on your schema, you get a secure API endpoint that has built-in authentication and authorization policy. We generate type-safe SDKs for Android, iOS, Flutter, and web. And in addition, we'll generate a tool definition for function calling of that query from agents. We start with our schema and define our query. In our query, you can see that we have security built in with the auth directive and are pulling movies within a certain date range. Data Connect will take the schema and query and generate SQL to maintain your schema inside your Cloud SQL instance. We define a secure API endpoint that can be called, and we define type-safe SDKs that can be called with a single line from your client. Data Connect accelerates your app development by abstracting the infrastructure away that you need to manage to run your app. It connects Cloud SQL to your app, and so you simply need to define the queries and mutations from your app with the integrated authentication and authorization policies. Data Connect translates the GraphQL into SQL to read and write data to that Cloud SQL instance. Data Connect even handles embedding generation from Vertex AI to enable semantic search in your apps. That was the search that looked through the movie catalog in the demo based on the meaning of the search instead of the exact search word. So, how does semantic search work? A vector embedding represents the meaning of an object as the AI understands it in a multidimensional space. So let's break down what that means. In my example here, I have a two-dimensional space that already has some embeddings generated for two places. One is a mountain, and the other is a beach. If I search for snow activities, the embedding will fall closer to the mountain, so the search will return the data in my database associated with the mountain. If I search for surfing, the AI knows that surfing is related to the beach, so it will return the data associated with the beach embedding from my database. Data Connect makes it really easy to create these vector embeddings with Vertex AI and store them in Cloud SQL. With a single line in a mutation, Data Connect will generate the vector embedding and write the data into Data Connect. You write the mutation, and Data Connect handles the rest. The same goes for semantic search with vector embeddings. When the user enters a search term, Data Connect will generate an embedding from Vertex AI and then execute a similarity search for related data within Cloud SQL. Same as before, you write the query and Data Connect does the rest. Now that we've learned about the technology that enabled us to build the app, I'll hand it off to Michael to dive into the code.
Thanks, Tyler. Data Connect starts with a schema. Here you can see my schema with all the types for our movie app. As I update the schema or add new fields, they'll be automatically migrated in my local emulator environment and can be deployed to production using the Firebase CLI. Once I have my schema, Data Connect automatically generates a rich GraphQL querying API for my app. Switching over to my queries, I start by defining fragments. Fragments let me fetch the same data in multiple places in my queries, such as the basic movie review information, including average review rating, or the user information for a particular review. With Data Connect, I can construct efficient queries that fetch all the data I need in a single request. Even though our app's homepage contains multiple distinct sections, and each section contains nested relational information, I can retrieve all of that data using a single homepage query. I add a field for new releases, for top-rated movies, and for recent reviews. I add the fragments to get the data my UI needs, and I'm ready to go. But what about something more complex, like aggregations or the semantic search we demoed earlier? Data Connect has a built-in integration with Vertex AI to enable text embedding directly from our GraphQL interface. For our movie search, we compare an embedding of the user's query against the already generated embeddings of the movie titles and descriptions in our database. To pull in review statistics for our movies, I used a view type. This special type allows me to write arbitrary SQL select statements and bind them to GraphQL data. View types can be integrated into your data model relationally so that when I query a movie, I can also pull its average review rating, for instance. When you're ready to test out any of your queries, you can do it right from your IDE using the built-in query runner that's part of the Data Connect VS Code extension. If you want a little help writing your queries, you can even describe your query in natural language, and Gemini will help you write it using the current schema for your specific application. Now that we've built our query, how do we integrate it into the application? Let's take a look at the Browse Movie page, which has rich interactivity as the user filters to find the movie they want. Data Connect brings the end-to-end development experience together by generating a strongly typed SDK based on your queries that can be used directly in your app. Using our new React bindings, all I need to do is prepare the variables I want to pass from the user interface and pass them to the React hook that was automatically generated the moment I saved my query. As the variables change from user input, the query is automatically re-executed and the data is updated. I'm pretty happy with the basics of our app, but there's a new feature we've been working on that I'm even more excited about. A movie recommendations agent that will pick the perfect personalized movie for my users to watch. To create this agent, we'll combine Data Connect's querying power with Gemini's intelligence using the GenKit framework. Tyler, can you talk a little about how the agent is going to work?
Thanks, Michael. We've seen how easy it is to build the backbone of an app with Data Connect. Let's take this to the next level and create an agent that can use tools to access data within our database. The first concept we should cover is retrieval augmented generation, otherwise known as RAG. In a normal conversation, a user will prompt an AI, which will give it an output. But if you want the AI to give a relevant result based on data in your database, you can use RAG to execute a semantic search and pass the context to the AI. The AI response will now contain the relevant data from your database. Let's add some more complexity to this. You've created an agent that can answer many types of questions. In order to answer these questions, it will use a spec from Data Connect that will tell it about the available tools, queries, and mutations it has to answer the user's questions. It will choose the tool, pass the right information from the prompt, and then return an output based on the data it pulled from the right tool. So we want to build an agent that can recommend the perfect movie to watch. In order to do that, we'll create multiple tools that the agent has at its disposal. A way to search movies, filter movies, search reviews, clarify a customer's question, and finally, recommend movies. The agent may make multiple calls to different tools to get the right information to answer the question of the user. And of course, we don't want to recommend a movie that the user has already watched. So we'll RAG in the user's past watch history and reviews. The general flow goes as follows. The user enters a prompt to the agent, and the past reviews and watch history are provided as context to the agent. The agent then chooses which tools to call and pulls data to try to answer the question from the user. The user can then request new recommendations or clarify their request. The agent then goes back with the new information and gathers additional data using the tools it thinks are best to answer its question. When successful, the user will accept the agent's recommendation. Michael, do you think we can add this to our movie app?
Yes, we can, Tyler. Let's dive in. To set the scene, let's take a quick look at the prompt that will drive our agent. It has detailed guidance to help the model use and find information to recommend the perfect movie. It also has access to a few tools already: Ask Question and Recommend Movies. Tools allow an LLM to request additional information either from the user or from data made available to it. It's what makes an agent an agent. You can see at the top that there's a to-do indicating that we need to add tools that can talk to the database. Let's do that now. One of the central concepts of Data Connect is what we call a connector. You can think of a connector as being a dedicated API for your application that's built for a specific purpose. Earlier, we were editing queries in the connector that was built for our web app, but for our agent, we're going to create a second connector. I've already created a tools connector directory and added some queries to it for my agent. Search movies to do a semantic search, filter movies to find movies by filtering based on various criteria, and search reviews to search through user reviews. Data Connect supports generating SDKs for JavaScript, Swift, Kotlin, and Dart, but it also has one more feature: generating tool definitions for LLMs. In my connector.yaml, I'll add an LLM tools entry and pick an output file. As soon as I save, the connector automatically generates the definitions file. Looking at the generated tools.json, you can see that it provides information about my Data Connect service, as well as JSON schema definitions and descriptions for each of the queries that I defined. This provides a great basis for working with any LLM's API, but we've made it even easier for GenKit users. GenKit is an open source SDK to build GenAI features server-side in JavaScript, Go, and Python. Here, I'm integrating it into my Next.js app and initializing it to use the Gemini 2.0 Flash model by default. GenKit is extensible through plugins, and the Firebase plugin includes a way to add Data Connect tools directly from the generated JSON file. I just need to add the path to my generated file and pass a reference to my Firebase app to configure the connection. Once I've done that, I can switch over to the GenKit Dev UI that lets me test and play with everything plugged into my app. I see new tools are available: db/search movies, db/filter movies, and db/search reviews. I can test these out and see that it is returning data from my application. And now that these tools are available to GenKit, I can add them to my prompt and complete that to-do. So now my agent can intelligently reason about when it might need to search movies and reviews to find a great movie to recommend. Let's take this new agent for a spin. When I visit the Next Watch feature of the app, I can see my recent watch history with an open spot for what the agent will recommend. I can pick from a few pre-selected prompts, or I can ask it for something I'm in the mood for. In this case, I'm going to prompt for something I can watch with my daughter. Based on this prompt, the agent will review my watch history, including any reviews I've written, to better understand what to recommend. It can either go straight to recommendations or, as we're seeing in this case, ask a clarifying question. Here, it's asked me what genre I want to watch. I'll say animation. A few seconds later, the agent has made a recommendation of 3 potential movies. And honestly, these all look interesting to me. But my daughter has been really interested in magic lately, so I'm going to refine the recommendations by saying that she's into magic and witches. The new set of recommendations includes movies that incorporate all of the information already provided, but refines it further based on the new request. With that, I can pick the perfect movie to watch tonight with my daughter. Data Connect speeds up the process of building both applications and agents by automatically generating the API endpoints, SDKs, and tool definitions for my application. Tyler, can you give us a recap of what we've done so far?
Happy to, Michael. We started off by building a connector on Data Connect that enables the web app to execute queries and mutations that read and write to Cloud SQL and execute semantic search with vector embeddings. We just created a new connector that contains tools that our agent on GenKit can call to power our movie agent experience. We encourage you to try this out yourself. You can clone the agent and movie app at the GitHub repo with the QR code. And if you want to just start with the app and semantic search, you can follow the step-by-step instructions with our code lab. Thank you, and happy hacking.